So now we come on to trace tables. The specification says that students should be able to use trace tables and visual inspection to determine how simple algorithms work and what their purpose is. So what is a trace table? Well, let's say we have an algorithm that looks something like this. This is in really basic pseudocode. What we can do is we can do this in our head, or probably a better idea in case you make a mistake is to do it on a little table. Just write this in the corner of the exam paper or something, or I'm using Excel because it's easier. What I'm going to do is I'm going to draw up a little table, and I'm going to trace how all of the values change. So this one is a really easy example. So let's say you're asked to solve this, or use a trace table to solve this in the situation A equals 10 and B equals 6. So A equals 10, B equals 6. I'm writing down what the variables equal at this step. Then we're going to go through. So A equals 10, B equals 6. Now we get to this line. C equals A times 2. Well, A times 2 is 10, so I'm going to put this on the next line to make it a bit clearer. C therefore must equal 20, right? Then we carry on. Now we say if B is greater than C. Well, is B greater than C? B is 6. B is not greater than C, so the answer is no. And now the output is no. So actually a lot of these tables will have a little column at the end that says output, and you can say no. Now let's say we're asked to do the same thing, but this time A is 5 and B is 10, or B is 11, that'd be easier. No, let's make it 9. No, let's not. Let's make it 11. So now here, same sort of thing. A is 5, B is 11. We go through. We say C is A times 2. Well, what's A times 2? A times 2 is 10. These are still 5 and 11. Then we keep going through. Is B greater than C? Well, 11 is greater than 10, so this time output yes. So we've been asked to trace two things. We saw that in the first example, it was a no. The second example is a yes. We can try a few more examples if we're still not sure. So I go, well, what if B was 9? That would be a little bit different. So if B was 9, then we'd go through, we'd say, what's double A? Double A is 10, then B is still 9. And this time, B is less than C, so this is no. So what this algorithm seems to be working out ultimately is the difference between B and C is the answer to double A. So it's saying, is B more or less than double A? And if B is more than twice whatever A is, that seems to be that this algorithm outputs yes. So that's what you'd say. This algorithm tests whether B is double A. That would be quite an easy example, and in the exam they tend to needlessly switch things around to make it as difficult as possible to test your trace tabling skills. So in this example, we don't know what this does yet, and hopefully this does something that you recognize. If not, we'll explain it. So let's say we do this in the case A equals 5. So A equals 5. Now B equals A minus 1, so we're going to call that 4. And now C equals A, so C is 5. That's the first step. Now we're getting into a while loop. You might not have seen these before. Essentially, a while loop checks whether the condition is true. If it is true, it does everything in the condition. Then it goes back and it checks it again. And it will keep going back and trying again until this condition is false. And it only checks that when it gets to the top. That's quite a key thing because some loops work differently. But it will go through, and every time it goes to the start again, it goes, is this the case? And if it is not, it will break out of the loop. And you see the way this is indented. This means this is part of the while loop. Sometimes you see end while to be really clear that like when you finish this, you go to here. But this is clear enough, I think. So we say while B is greater than 1, or B is greater than 1, so we're going to do this once. C equals C times B. What's C times B? C times B is 20, right? That seems right to me. Then B equals B minus 1. So subtract 1 from B. A is still 5. A hasn't been touched. Now we've finished this run of the loop. Now we go back up to the top and we check the condition. Is B greater than 1? Yes, it is. So we go through again. Now C equals C times B. Well, C is now 20. So C times the new B, because this is what B is now. C is now 20. B is now 3. The answer here is 60. Then b equals b minus 1, 2, and a is still unchanged. And then we go up again. We say, is b greater than 1? 2 is still greater than 1. So yes, c equals c times b. C times b is 120. B equals b minus 1. It's 1, and a is still unchanged. Now we go back up one more time, and now we say, is b greater than 1? No, 1 is not greater than 1. 1 is the same as 1, so it's not greater than 1. That means this loop now finishes because we did not meet the condition. We skip over it, and we carry on, and we say output C. Okay, well, the output now is 120. That's what you're going to be asked to do, and by writing this, you're going to get the marks because you've tracked all the variables through a run through. You're literally going through what happens now, what happens now, what happens now, what happens now, just like a computer would. And now you're going to be asked, what does this program do? Now, if this isn't clear to you, stop and think about it for a second. You probably should have encountered this concept. If you still don't know, try a few other things or write it out in terms of what's actually happening. If you're still not sure, actually, I'll give you one more second. Okay. So hopefully you've worked out this is a factorial. You might not know what factorials are, but 5 factorial, which is written like this, is 5 times 4 times 3 times 2 times 1. That's what a factorial is. And so if we did 3 factorial, that equals 3 times 2 times 1. And if we did 7 factorial, that would equal, whoops, to insert mode, 7 times 6 times, and you see where it's going there. Hopefully, I think you should know what a factorial is. It's a very common example. If you don't know what they are, you could probably write this out. You could say, well, if they put in 5, it does 5 times 4 times 2 times 2 times 1. If they put in 3, it does 3 times 2 times 1. Hence, I think that it does a times by every number 1 less than a until it gets to 1. I mean, technically, if you left the 1 off because this program doesn't use the 1, because obviously multiplying by 1 does nothing, you'd still get the marks. But a really good answer is this program calculates the factorial of a. If you're not quite confident, if you didn't know what a factorial was, you'd probably still get the marks if you explained this. Typically, a mark or 2 for the trace table, assuming it's correct, and a mark or 2 for understanding what the program does. So determine the purpose of simple algorithms, and it says you should be able to use trace tables and visual inspection, which is generally doing it in your head, which you can do if you feel confident, and to determine how simple algorithms work and what their purpose is. So do the trace table, think about it, work out the purpose. Easy.